Okay, so now we'll deal with some applications that use this C formula. So specifically, if you have a collection of n distinct objects and you wish to choose a set of k of those objects, then there are n choose or nck ways to do so. So just something specific about that. When we're talking about a set, it is really important to recognize that in a set, order doesn't matter. So very different from the P formula where the order did matter. This is what distinguishes the two. So for this question, we're going to say Sal is making grab bags for her little brother's birthday party. She's got 14 different types of candy, and each bag is going to consist of 3 different candies. How many different ways could she make, make the bags? Make them, something, I need something in there. Okay, so something else that we do need to note, so we do have the different candies, so we do need that to use this formula because it's distinct objects. So essentially what we're not choosing here is of like, maybe she has a pile of like 6,000 candies and there's 14 different types among the 6,000 candies. We're not thinking about the individual candies that are being grabbed, but what we're going to think about is the types of candies. So those are the distinct objects. So the objects are the type of candy, not the candy itself. So if we use this phrasing, then what we've got is that she's trying to choose a set of 3 or a subset of 3 from the bigger set of 14. So she has a collection of 14 types. She's trying to make an arrangement that consists of, not an arrangement, a set of exactly, how many was it? 3. And so this is precisely the phrasing of using that 14C3 formula. And so I'm going to actually write out the whole formula here. So 14 factorial over 3 factorial times 11 factorial. And so if we work that out in the calculator, it should be 364. So yeah, so again, just to kind of explain this formula and where it's coming from, another way that we could think of this formula is to tie it back to something we already talked about, that finding arrangements with repetitions. So the other thing that we could have done is considered the 14 candies, or the 14 types. So what we're going to think about is these slots. What we're going to have is either 3 in the bag and 11 not in the bag. So if we've got these 14 types, we can think of them as like our choices of whether or not something are in the bag or out of the bag. So like we could have these 14 things being distinguished as like whatever types of candy they are. And then what it actually becomes is, how do we arrange the in bag and the not in bag across those 14 types? And so these, those 3 in bag and the 14 not in bag actually become sort of like a repetition, because they're just sort of like a placement. So it's 14 total, but then, so of those 14 total, it doesn't really matter if we jumble up the 3 that are in the bag and if we jumble up the 11 that aren't in the bag. So the order within those 3 and within those 11 doesn't actually matter. So it's sort of just like repetitions. and we get basically the exact same formula. So that's just a way that you can think of this combination formula. And that is essentially it. That's how it is going to work. The n factorial over n minus k factorial of the formula. So this part here, this figures out the number of arrangements of those k objects. And then within those arrangements, we're going to divide out the k factorial arrangements that exist because they don't matter. They're not actually distinguished from each other. So that's sort of just where it comes from. We'll do some more examples. All right, a second example. This one's for the gamblers. In poker, a full house is going to be a 5-card hand for standard deck, 52 cards, with 2 cards of the same number or face. So we're talking about like the ace, 1, 2, jack, queen, king, and 3 other cards of the same number or face. So I just wrote an example of what a full house might look like. So 3 aces and 2 5s. They do have to be different numbers or faces because we can't have 5 of the same. So how many different full houses are there? So this question is a little bit more involved because it's got a couple of different things to think about. There are different ways that we could parse this, but to me, the easiest way to think of this is that we're going to split this into 2 actions. So what I'm going to do is pick my number or face, which I'm just going to call NF. So I'm going to pick my number or face for the triple. So step 1. Maybe actually I'll do this. And then step 2 is going to be pick the number or face for the pair. And those 2 things are distinguished. The triple is different from the pair, so that's something to be mindful of. And then, so if we do that, the action that would go between them, because I'm trying to construct this one hand of cards, is I would get the triple, then I would get the pair. It's definitely not exclusive. It's a then, not an or. So what I'm going to do then, yeah, is so pick my number or face for the triple. So for that, there is 13 combinations, 13 possibilities for the triple. And then if I want to pick my number or face for the pair, one of them is now gone. I definitely cannot have a pair that has the same face as the triple because that's too many cards, right? There's only 4 different suits. So for the pair now, there's only 12 left. So there's 13 times 12 ways that we could arrange this. So this is one way of thinking of it. There's more than one way to split this up. You could also think of this, if you like, as being 13p2. So in this case, order does matter because if we assigned like aces to the triple and 5s to the pair, it would be a different hand than if I gave 5s to the triple and aces to the pair. So that's why we would use the P formula. The order does matter, and I'm picking 2 things of 13. So we get that 13 times 12. And so what I can do after that, maybe I can actually work out that number. So that's 156. Then I'm going to figure out what goes on within the triple and within the pair. And again, it's then I'm doing this thing. So after that, so I'm going to figure out the arrangements in the triple for that given number. So I'm just going to pause it. So yeah, so what we're going to do now is choose the triple within the specified number or face, and then similarly we'll want to choose the pair. So within the number or face, there's 4 cards, there's 4 suits. And it's a triple, so we're going to choose 3 from the 4 suits. So it's going to be 4 choose 3, or that 4 over 3 if you like. You can calculate this or plug it in, but that should just be 4. You could think of this basically, it's easier to think of is which card are you going to leave out. Yeah, you've got 4. 4 in total and you're choosing 3. So yeah, there's only 4 sets you can make by just omitting one of the 4 cards. And then choosing the pair. So again, there's 4 suits and I want 2 cards. So that's going to be 4C2. That one is a little bit more work, but just plug it in and we'll get 6. And again, it's that word then between it. So once we have the number or whatever face it is, once that's picked, there's only going to be 4 times 6 ways that we can choose the suits within that. So that's going to be 24. And it's a big then between them. So it's 156 times 24 is 3,744. So that should be your number there.